Which standard deviation? Sample standard deviation. If you don't have any standard deviation, you can't do anything.
If it had the standard deviation of like all kids, right, and then it would be.
Then it would have been a z-squared.
Yeah, okay.
All right. So here's my plan. We have a couple things to finish up from chapter 9. We have hypothesis tests for proportions to use, right? That's one thing. So I'm going to focus on that right now. We'll talk about the different types of errors. If you've done any homework at all, you've run into that, hopefully. I can see in your face, you're like, nope. All right. So we'll talk about what the hell those are. If I'm doing a test about it.
I have a question. So you know how yesterday you were saying if there's an equal sign, it automatically goes into the...
Yeah, so if it's equals, greater than equal to, or less than or equal to. Those all have equal signs.
So what's the wording that it would say, like, greater than or equal to in a problem? Like, I understand when it would be equal to, but when would it be greater
So
than?
if I said the mean is at most 9, what would that look like? The mean is at most 9. What symbol would I use? Yeah. It's at most 9.
So when it's at most...
So if that was my claim, I claim that it's at most 9, where would I put this? Yes. Put it in the home.
And if it was at least 9, then it would be greater than still...
Greater than equal to, yeah. It would still be. Yeah.
Okay.
Alright, so the null hypothesis always gets the statement that has the equal sign. That's why I make you write your claim down, you figure out which one it goes into, and then the other one is the opposite. Because they're the old man and the concept that disagree with each other. Okay. Hypothesis test for proportions. English better maybe. Oh, I got red too. Oh, that sucks. Red sucks. All right. So all 5 steps are still there. They're all fundamentally the same. Except now, if I say we believe the percentage is let's do one of those things. Is at least 20%. What's the claim in Mathish? And where does it go? Here's one little tiny difference. It should be a very obvious difference. If that's the claim, how do I write that in Mathish? There's English. It doesn't look like a Mathish.
X is less than or equal to very small percentage.
Greater than or equal to...
P? Is greater than equal to, I heard that. 0.2, I love it. Don't use no 20%. Make it into a number when you want to start doing math shit to it. 20% is something humans created to make things make more sense for us. Math says that's nice for you guys. Use what the hell it is really. It's really 0.2. So where would that go, of course? Yeah, HO, because it's got an equal sign in it. So what would this be? Less than. And then it would be a 1 delta. So one little difference is don't use a mu when you're talking about percentages. The hell sense does that make? If we're talking about percentages, use P. Yes?
Is this chapter 10 or are we still in chapter 9?
Still chapter 9. Chapter 10 deals with doing 2 samples instead of 1. So yeah, that's a whole other thing. Alright, so here come the big differences. Alright, this is a very small difference. One of the first big differences is use T or use Z scores or T, but right now, bam! No, T's don't work for no. You don't use T's ever for a percentage problem. Why? Because I create the standard deviation. I always know the population standard deviation because I create it. I don't know if you guys kind of with me. That's why. How many confidence interval formulas are there for an X bar? Oh shit! Come on. What are the confidence interval formulas? X bar plus or minus Z stuff. X bar plus or minus T stuff. How many formulas are there for P hat? 1. You never use a t-score with percentages because you create the population standard deviation as you work. So you never not know it, kind of make it. So I actually will probably be nice and say, do you use z-scores or nothing? Trying to remind you, t's not even an option. But what do I check? What did I check here? Hopefully in part on the number 1 on the quiz, how did you figure out it was normal enough? The 30 whatever, 40 whatever, 50 whatever parents, n had to be greater than 30. What do I do for percentages though? What's greater than 5? Yeah, NP, NQ. That's what I got to check, right? So use the right symbol, do the right check. Part C is the same. I'm going to give you an alpha, right? And you're going to figure out where the rejection region is. So that third step's the same. It's the fourth step that we got to have some trouble. Now, obviously, I can't use this formula that we've been using. It's actually that formula, but oh well. I can't use that because I don't have means. This is not a problem about means. Shit. So, what I'm going to use then, what makes sense on the top is, how am I going to check this claim? What would I do to check the claim? Here's a claim. What do I immediately do as a statistician? Somebody's got a claim. I think at least 20% of millennials don't know how to use a rotary phone. Okay. There's a video about these guys trying to use a rotary phone. They have no idea. Rotary phone, you go,
Hello?
so that's, if that's my claim, how would you immediately go check it out? What would you do? Well, how would you check it out? There's a claim. I think 20% of all millennials, at least 20%, don't know how to use a rotary phone. How would you start to check it out? What would you go do? Huh? I love it. You're like, let's make it 31. Or let's make it 500, because we got to make sure we're going to eventually do this, okay? But whatever. Get a sample and take, and then see what percentage of the sample. What's the symbol for that? What's the percentage of the sample? What's the symbol for that? P hat. So I'm going to get a percentage from my sample, and I want to see how far that is away from that. So we got the top. The top is just like x bar minus mu. It's my data minus the claim number, the middle. So now I'm still doing my data minus the claim number. I don't know if you remember earlier this semester I said the z-score formula is always the same. Well, now you're really going to look at me weird. All right. Is everybody kind of with me? So the changes are use a p instead of a mu. Ooh. Do the right check. C's the same. Now I've got to use the right formula. I don't have means. I don't have standard deviations. Yes?
So the hat is your data.
Yes.
P is their data.
Sort of like X with a bar on its head is our data, our sample mean, right? P with a hat on its head is our percentage from the sample that we took. Yes. So I need to figure out what's going to go down here. What idea has to go down here? Standard deviation, some kind of spread, right? So recall. I have it over there. The formula for the which piece of this is acting like the spread? Well, it is the spread, but which piece of this is in the right place to be the spread compared to this? What's the spread in this one? That. What's the spread in percentage problems? That. You guys... No? Come on, you can do this. That is, in fact, remember how we started this? We started with square root of NPQ, which is the spread, which is the standard deviation for binomial percentage problems. And then we had to adjust it a little bit to be for percentages alone. That is the standard deviation. That is, right there. I can't read you guys at all. You're all like...
So it's the whole thing goes in the bottom?
What's up?
The whole thing goes in the bottom?
The whole damn thing goes on the bottom. Now here's the other trick to this. In this problem, for this problem, do I know what P is. And what does P represent? Percentage of?
Successes.
Of the population. What represents the sample percentage? P hat. Sweet. So when I'm making confidence intervals, do I know what P is? No, that's the whole point. I'm trying to estimate what P is with my P hats and my Q hats. So when do I have to use P hat and Q hat? When I don't know what the shit P is. In this problem, I know what the shit P is. So I'm going to use this, but I don't have to use the hatted ones, which is an awesome name for a band. The hatted ones, no? Maybe it's just me. We are the hatted ones. And they don't wear hats. This is all sarcasm. No. So that's how you calculate how far apart these are. Because remember, the whole idea of this is what you find in the sample has to be really far away from the number involved in the claim, the 20% that was up there, right? So, but how do I measure distance involves how spread out everything is, and that's the spread for percentages. So that's the really big difference. The check, we kind of know already. This is brand new. This Z-score formula is brand new. You should kind of expect this. We're not going to have X bar. We're not going to have mu. We're not going to have sigma. We got to use everything involving P's and Q's and N's for this problem. All right, so let's try one out. Let's see. I got a little. You're not going to believe this. Get a handout with. We'll do one side together, and then I'll let you guys do the other side on your own. Okay.
See, I calculated both
Well, that's the basic idea of hypothesis test. Is how do you show evidence that something isn't equal to something else? Find that it's really far away. And that rejection region step is what defines the far enough away.
I spent 10 minutes looking at that too.
For the first one on the quiz? Yes, that was S. Can you see it?
You got the best right there. I don't have all the time to do the whole percentile, so I'll just write real fast and really graph everything, and the Z-score, and at least I get something. So I'm looking
All right. You're so excited about this. Yay, Jeff. There's only like 8 more kinds of hypothesis. No. Yeah. More. It's the only other major kind. All right, guys, read through that. What do you guys, hopefully most of you read through this already. Do you guys remember Occupy Wall Street? No. Okay. That's good. No. Anyway, so it lived for a little bit, the whole 1% kind of thing and all that kind of stuff. We feel that at least 20% of Americans opposed the Occupy Wall Street movement at its height. And I've sampled 996 Americans, taking the time to show blah, 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 blah. So, what's the claim that's being made? Kind of got you guys ready for this.
P is greater than or equal to
0.2.
1%.
Never use a percentage. It'll mess you up later. So what's which one does that go in for? We already know from earlier. And then what's the high going to be? So how many tail tests is this going to be? Why do I know it's one tail? Less than. I only care about samples that show up on that side. Does that make sense? That's it. That's all. It's less than. Do I care if they show up above? No. In fact, if they show up above, that's bad for me if I think it's less.
I thought greater than, or I thought it was like equal to 2 tails.
Yeah, that's what I thought.
I love you guys. I love you guys. Do I have any strictly equal to anywhere up here? Nope. Nope. What always sets up the rejection region? H1 does. Always. Now, what's our claim happen to be? HO. So how are we going to write our conclusion? We're going to base it on HO. But what always sets up the rejection? What can I show evidence for? The thing that does not equal. I can't show evidence for equal. I can show evidence for looks like it's less. So what am I kind of rooting for as I do this problem? If I'm the one who made this claim, I'm hoping I fail to reject this, because that's what I think.
So if the H1 is greater than it's always going to be 2 tails?
Just if it's a regular.
All right. Less than, I only care if they show up down there. That's one tail, right? There, one tail. Greater than, I only care if they show up there. Right, that's one tail. Not equal to. That says not equal to. How can I be not equal to something? Less or greater, that would be 2 tails. That's it. Where would you find evidence to show that H1 looks right? That's what sets up how many tails it is. And, you know. So where would I find evidence for P less than 0.2 if I found a sample that was way less than 0.2? One direction. All right. So step 1. What do I do in B here? What do I do for the second step?
Yep.
What do I check?
Oh,
Good, yes, N times P. I love it. What's N? 996. What's P? 0.2. I love it. Kick ass. So the whole thing about hypothesis test is, okay, let's assume that it is 0.2. All right, so we know that P is 0.2. In fact, I want to say this. There are problems in the homework where they give you sigma and S. They give you sigma and S. Screw S. I'm not going to use that shit. I'm going to use the real one. I'm going to use sigma. So if they give you sigma and S, you use sigma. You use z-scores for that because you know the population distribution. Now be careful. Why does your calculator give you both? Has no idea what the hell you just put into it. Just like, here you go, dude. Figure it out. If I put a sample in, I better use frickin' S. I don't also know sigma. It's not a population. Okay. So what is 996 times 0.2? 199. And that's at least 5. And then I also checked NQ. What's Q? What? What's Q? 0.8. Okay. And then this is 796. Is that what you said? And that's at least 5. Okay. So that's the check to make sure what? If it was normal enough, I like it. So, I was trying to hear everybody. Normal enough, check. So I'm allowed to use z-scores. If it wasn't normal enough, you can't do shit. I like it. How you guys? This should feel very familiar. It's not very different from the ones we did yesterday. Right? And you're all like, you know what we did yesterday. All right, what do we do next? Yeah, get the rejection region. I want a alpha of, it's called the level of significance. I don't think I've used that phrase yet. Alpha is called the level of significance. If I pass a 0.05 test, that is more significant than if I pass a 0.10 test. It's harder to pass a lower alpha. It's harder to get that far out. So that's why we call it the level of significance. You have to really know that? No. So that's 0.05. So I can use z-scores. It's a one-tail test. Where's the tail at? Yeah, less than what's down here. So for a 0.05 one-tail test, what's the z-score? All right, so what do I write here? Yes, negative 1.645. Because it's down there, right? Again, we're the humans. You don't just take what the chart says and go, put that down. No. It's down. You better put a negative on it. So how do I say this in words then? If I had a hammer, no, if Z star less than, what can we do?
Reject the whole.
Reject the hoe. Nick is on that. Which means you can also support no. You're messing with this person's brain. Get away from me, I love you. Support the high. Kind of makes sense. If it looks like you can say this one dude is wrong, that means it looks like you can say the other dude's right. Are these two situations? No, this is one situation. Okay. So now that we've set up what far enough away is, we have to go see how far away we got. How do you get p hat? Now we got to do our sample information, right? What's p hat? 183 over 996. $184? Like that? Okay. Let me stop here for a second. And now I get everything I need. My Z-star formula is P hat minus P over square root of PQ over N. P hat is the 0.184. What's P? 0.2. And then I got square root of 0.2 times 0.8 divided by N, 996. Oh boy, have fun trying to get that in the calculator right. You gotta make sure you put the top in parentheses, and you gotta make sure you don't close the square root symbol too soon. You wanna make sure all that shit's in the square root on the bottom. Let's see if we all get the same number. Damn it. My poor little calculator symbol. No, this is a dead one. Thanks, guys. I love it. This man needs help. Let's help him out. Okay.
So you don't put the second point two in parentheses?
Do what?
On the second point two in parentheses?
No, you just need parentheses around the top. What do you mean? Now, you could do this on the old calculators, and the new calculator should be really obvious that you get everything under the square root symbol because it grows. Yes?
9 and 10 is going to be on the test on Tuesday, right?
Yes. Yeah, we'll see about 10. I don't know. Yes? What is it? Oh, I see. Oh, I see. No, that's fine. 5. I got negative 1.26.
Just add one more step.
All right. What are you guys getting?
Negative 1.262.
Yeah, I got negative 1.26. Now right there we know the answer. What's the answer going to be? Did we make it far enough away? Uh-oh.
We failed to reject.
We failed. We didn't make it in there, which is actually good for us. So there's the test will either succeed or fail. If that's good or bad depends on what the hell we're testing. What was our claim, right? But before we get there, what's the p-value? No. No. Do I have any more z-scores? No. Let's see, anybody able to do that? P-value. Yes. P-value is the area in the tail of your z-score. So the p-value is 0.1038. How did I get that? How did she get that? We just looked that up, of course. Get the area in the tail that z-score makes. What's alpha? Alpha is, where's alpha in this picture? Where is it? Where's alpha?
The shaded area.
Shaded area. It's the area in the tail that the benchmark z-score makes. The p-value is the area in the tail that your z-score makes. That's it. That's it. Okay. So we have failed to reject the hoe, failed to support the high. Which language am I going to use for the conclusion? What language am I going to use for the conclusion?
Have not have sufficient evidence to reject.
All right, I'm going to make a special test for Nick. What phrasing am I going to use? Phrasing.
We have not.
Our claim was HO, so that's it. Just that language.
You know, to reject from.
Yeah, now you're going to, in the next thing, you're going to actually explain what the hell that means, right? Failed. We have, no, we failed. We have not found sufficient evidence. I mean, when do you find evidence? When you make it in the rejection region, when you make it far away, enough away. And when you don't get in there, you didn't find evidence. We have not found sufficient evidence to reject the claim that at least, and I just steal from the problem, 20% of people opposed what looks like a Harry Potter test, but it's the owls, not the owls. All right, you guys do the problem on the other side. Yeah.
I was concerned with